This is Note-Taking Guide 8.4 for Mathematical Decision Making for Life. Today we're going to talk about something called the law of detachment and syllogism. So it's just a couple of rules that still have to go along with those statements that we've been working on before in the reasoning. So this first section here says the laws of deductive reasoning are used to draw conclusions from given information. Sometimes this is straightforward, but in other cases you have to be thoughtful and careful about what you conclude. Here's the law of detachment. So it says, given P, then Q. So again, this is an if-then statement that, if you remember from last time, that arrow means if-then. So what that says is if P, then Q. So if we have P, what can we conclude? These three dots today are the first time we've seen those. They mean therefore. So it says if P right here, then Q. So if we have P, we can therefore conclude that we have Q. So that's the law of detachment, and the way that it looks in symbol form is just like that. Okay. So what we're going to do now is we're going to see if we can use that law of detachment to kind of figure out what conclusions can be drawn here in example 1. So it says, if it is spring, then flowers blossom. It is spring. What conclusions can be found then? Well, of course we can tell that's super easy. We know that the flowers are going to blossom. And that's, that was an easy one to just listen to and figure that out. But if we were like, I don't know what we can conclude from that, then there's an easier way to do that with the symbols. We could say that P represents the spring and Q represents the flowers blooming. And we know that P, if P happens, then Q happens. So again, if we went up here to the rule, so if P, then Q, we know is happening, then they gave me P again, so I know that Q is going to happen. So that's kind of the way that law rule works. So here's example number 2, and it says be careful. So let's just read through it and see whether or not we actually think it works or if we can conclude anything from it. So it says, given, if an animal is a chicken, then it hatched. So an animal is a chicken, let's call that P, and it hatched is Q. Perry the platypus, I'm sorry, I didn't say that right. Perry the platypus hatched from an egg. So we have P, then Q. Now it wants to say, well, we have Q, so what can we conclude? Well, you guys, it doesn't make sense that Perry the platypus would be a chicken, because that's what we're supposed to conclude, that we would get P. But again, that doesn't make sense. P says that he would be a chicken. And we already know that Perry the platypus is a platypus. So this doesn't work. To think through the process sometimes and make conclusions from it, we need to make sure that it actually works when we do that. So this example right here is an example of something not being true. And therefore, we can't conclude that Perry the platypus is a chicken, so we're just going to put that as not true. All right, example 3. If I ate dinner, then I am not hungry. I am hungry. So here we go. P is I ate dinner. Q is I'm not hungry. So I have P, if P, then Q. Now this part, I am hungry, is Q again. So I have Q, so what do I get to conclude? I can conclude, so it says, if I ate dinner, then I am not hungry. Okay? So Q was not hungry. This time I have I am hungry, which is not Q. So what is going to happen there? Well, then I'm going to get not P. Because if I am hungry, that means I didn't eat dinner. So we did not eat dinner if we are hungry. So in a conditional statement, if a conditional statement is true, its contrapositive is also true. So if you have P if P then Q, then you have if not P, then not Q, or not Q, then not P. Okay, the next law is the law of syllogism, and what it says up here is at the top is it says if P then Q, if Q then R. So if you notice those Q's are in common there. So if P makes Q happen and Q makes R happen, then guess what we have here? We know that P and R are going to be together if P then R. So let me show you how that works in this example. It says if it's spring, then flowers blossom. So P is flower, or if it's spring, Q is they blossom. So if flowers blossom, which we labeled Q already, so we're going to label that Q again, then I get allergies. That's going to be R. So what conclusions can be drawn? Well, again, we have P, if P then Q, and then we have if Q then R. Again, those Q's are the same there, which means I can conclude P if P then R. So what does that really mean with our example here? It means if it is spring, then I get allergies. So if it's spring, then I get allergies. All right, example 2 here. Given if Laura saves her money, then she can buy clothes. So if Laura saves her money as P, she can buy clothes as Q. Laura saves her money, which is P again, then she will be happy. Being happy will be R. So what I have here is I have P goes to Q, and then P goes to R. This time it's the P's that are the same, so I can use Q going to R, which means if we're looking at it, if she buys clothes is what Q stands for, and then R is she will be happy. So we can conclude that from example 2. All right, example 3, last example today, it says, if you are naughty, then Santa does not come. Okay, so being naughty is P. Santa does not come is Q. If your stocking is filled, so that's going to be R, then Santa came. Now up here, Q was did not come. Here Santa came, which means that's going to be not Q. It has to be the opposite of Q, so not Q. So what conclusions can you draw? It says Jeff is naughty. So if Jeff is naughty, then what can we conclude? We conclude that Santa did not come. So even though that had a couple of different pieces of information in there, when we read through it, we could still figure out what would happen if Jeff was naughty, because it says if you're naughty, then Santa comes. So we can conclude that Santa did not come, and we can also conclude that his stocking is empty, because it would be not P, not Q on that, or not Q, not R. All right, thanks for watching, you guys. Good luck with your homework.